Yeah, well, today we're going to keep talking about circles. In the last lesson, we talked about angles and how they interacted with circles and created arcs when the vertex of the angle was at the center of the circle. And now we're going to talk about angles and how they interact with arcs when the vertex of the angle is on the actual circle. So if you look at my first circle over here, we have an angle X, W, Y. And hopefully you can see that the vertex W is on the actual circle. And so this is my angle. And that angle intercepts. We talked about intercepting means it catches. It's sort of like these two sides of the angle are holding this arc. This is called the intercepted arc. And this type of angle is called an inscribed angle. And so last time when the vertex was at the center of the circle, you can see the center is right here. When the angle is at the center, we called it a central angle. And when our vertex is on the circle like this one is, the vertex W of this red angle, it's called an inscribed angle. So this inscribed angle still intercepts an arc, but the relationship is different than the relationship for a central angle. For a central angle, the angle and its arc were the same degree measure. In this case, the angle is going to be smaller than the arc. It's going to have a smaller degree measure. And so the relationship here is that our arc is equal to 2 times the angle. And if you want to say arc measure or angle measure, that's fine. Or you can say like M arc, M angle, whatever works best for you. Just so that you know that this is the measure of the arc and the measure of the angle. So if we multiply the angle measure by 2, we can find the arc measure. The opposite of that would be that the angle measure is equal to the arc divided by 2. These give the same relationship. In both relationships, the arc measure is twice as big. It's just a different way of looking at it. So I would recommend to you to pick one version of this relationship, whether it's this version where you multiply the angle by 2 to get the arc, or this version where you divide the arc by 2 to get the angle. You take one of those versions and use that version every time to solve for missing arc or angle measures. And so I like to use the one I circled in yellow. I wrote in orange. We usually like to multiply more than divide. It looks cleaner because there's no fraction. So you just choose the one that's best for you. And so I have this angle here, excuse me, this angle that's 80 degrees. It intercepts this arc XY. And we want to know how big arc XY is. That's where we put the question mark. And so I can write in here that my arc measure, the measure of arc XY, should be equal to 2 times the measure of angle XWY. And our arc XY we are calling question mark. And our angle XWY we have here is 80 degrees, so 2 times 80. Now, if this piece is a little too messy or complicated for you, that's okay. You can just skip right to this step where we plug in to our relationship. It's important to continually write this relationship every time you use it so you can memorize it. So we just do 2 times 80, and we can find that that arc that's intercepted by our inscribed angle is 160 degrees. It's twice as big. So anytime we have an angle where its vertex is on the center, I always like to highlight or show myself in some way what angle I have here. We want to know how big that is. It's inscribed because its vertex is on the circle. We can go find the arc that it intercepts. It's this one. And we would call that arc WX. So we have a relationship here between this angle WVX and this arc WX. It's that the angle or the arc is equal to 2 times the angle. Well, right now we know the angle is question mark, so we have 2 question mark. And we need to know how long the arc is. Well, these other pieces we know the whole circle is 360. So I'm going to find this yellow arc measure by doing 360 minus the other 2 arcs that we know. So I get this arc to be 144 degrees. Please ask if it's confusing to you how I got that. And so I'm going to plug that in here. To finish solving this, I need to divide both sides by 2, and I get my angle measure to be 72 degrees. So we can use this relationship much like we did central angles to find missing arc lengths, to find missing angle measures. The first thing to establish is what kind of angle do I have? Where is my vertex? Is it at the center? In this case, nope, it's not at the center. Now we ask, is it on the circle? Yes, it is on the circle. And so we have this relationship where my arc is equal to 2 times my angle. And again, if you prefer this method, angle equals arc divided by 2, that's fine. They both are telling us the same relationship, that the arc is twice as big as the angle. It's just a matter of which way you look at it. So we are going to get another type of angle where the vertex is on the circle. And we can treat these angles the same as an inscribed angle. I don't think this is necessarily called an inscribed angle, but the relationship exists the same way. I have this angle whose vertex is on the circle, vertex Q, and it intercepts this arc. In this case, it's not sort of holding the arc, it's kind of eating the arc. If you think about it, it looks like I'm eating this arc. But the relationship is the same. Our arc is equal to 2 times the angle. And I'm just going to keep using this one. This is the one I like best. It's okay if you like the other way. And you can see in here we have some different language. So far, we've been dealing with segments that are inside of circles, and those segments are called chords. We can talk about those more later. And we'll talk about these words tangent and secant more later in another lesson. But a tangent is a line that touches a circle once, much like this one does. And a secant is a line that intersects a circle twice, much like this one does. And so these are the types of lines that are creating this scenario where I have an angle with a vertex on the circle that's intercepting this arc. And so the relationship is the same again as an inscribed angle. And so our arc measure here is 92 degrees. And our angle measure is question mark. That's what we're trying to figure out. So to solve for our missing angle, we can divide both sides by 2 here. And we can get that our angle measure is 46 degrees, half as big as the arc that it's intercepting. So again, anytime, whether it's this type of picture or whether it's a picture like this where we have an inscribed angle, the relationship is going to be the same. And I really recommend, let's call out the angle that we're talking about. That angle is 40 degrees. Let's call out the arc that it's intercepting. It's intercepting that arc that we're looking for. Arc BC is what we're looking for. And so our arc is going to be equal to 2 times our angle. In this case, our arc is question mark. It's what we're looking for. And our angle is 40 degrees. So we can multiply 40 by 2 and get that our arc is 80 degrees, twice as big as the angle. So please make sure if you have any questions, you ask for them. You'll notice that I did put some questions before this. So make sure obviously you answer those questions. You have to answer them to move on. There's going to be a couple questions here about those problems that we just looked at. So make sure you answer those. If you have questions at all throughout this, make sure you do get them answered so that you can do your best and you can learn the most and take the most from this lesson. Take your time and good luck.